Uh, More examples. Let's do, what's the integral of sine x minus cosine x? Let's make it sine x minus 3 cosine x. What's the integral of sine? Derivative of sine is regular cosine, but the integral of sine is negative cosine x. Minus 3, what's the integral of cosine x? Derivative of sine is cosine, so the integral of cosine is sine. This is the one that doesn't need a minus sign. Plus c. Is this right? What's the derivative of that? The derivative of negative cosine is negative negative sine minus 3 cosine x plus 0. Yes, that's what I was supposed to get. Let's do a definite integral now that we know all this stuff. What's the integral from negative 2 to 1 of x squared? Do it by hand. We remember a calculator is capable of doing this problem, and that's good to check your answer, but on the exam I'm going to be asking you to, show the work. What's the integral of x? Oh, on exam 3, by the way, in case you're seeing this before exam 2b, this is all exam 3 stuff. What's the integral of this? The way to do it, so the way we write out a definite integral is we do the indefinite integral. What's the antiderivative of x squared? Or what's an antiderivative of x squared? It's 1/3 x cubed. We would usually put a plus c. The plus c here doesn't matter, and we won't usually write it when we're doing a definite integral. Because there are the little numbers here, the plus c doesn't matter. We'll leave it there and see why it doesn't matter for this one time. I need to take that function. Remember, this brackets notation means I have found an antiderivative, and now I need to take that antiderivative, plug in 1, plug in negative 2, subtract. What do I get when I plug in 1? I get 1/3 of 1 cubed plus c. Minus, what do I get when I plug in negative 2? I get 1/3 of negative 2 cubed plus c. This makes 1/3 plus c minus negative 2 cubed is negative 8. So I have minus negative 8 makes positive 8/3. The minus hit that. The minus also hits to hit that. I get a minus c. This plus c minus c cancels is why I didn't need to write the plus c in there. When you have a definite integral, the plus c is going to cancel out anyway. I get 9/3, which is 3. This is a thing where if I had asked my calculator to evaluate that, it would have given me a 3. I can do that. Let's do one more where the plus c actually matters. There will be problems of the form, find a function h of x, where h of 1 is 3, and h prime of x is the square root of x. Focus on the second part first. By the way, hey, notice that this is a problem that in exam 2b, I would have said, here's the derivative, and also here's an extra piece of information. Tell me some stuff about a function. I had a lot where I was saying, fill in this chart. Give me some table of values. We're now at the next level of that problem where I can not only tell you some values, I can come up with an entire formula for that function that'll give you all the values if you want them. How do I do that? Well, I start with the derivative needs to be the square root of x. So h of x needs to be an antiderivative of the square root of x. Square root of x is x to the 1/2. The integral of x to the 1/2 is I need to add 1 to the exponent, 3/2, divide by that new number out front. Dividing by 3/2 means writing 2/3. So I get 2/3 x to the 3/2 plus c. Does this function have h of 1 equals 3? This is where the plus c comes in. There are infinitely many functions whose derivative is the square root of x, but only one of those will have when you plug in 1 you get 3. The idea now is all the antiderivatives are this plus c. Which one of these choices of c will make h of 1 equal 3? Well, that's not hard to solve. H of 1 is 2/3 1 to the 3/2 plus c needs to be 3. I set the thing equal to 3 and solve. It turns out to always be easy to solve, because you just need to subtract whatever this was. This could be messy, but it's just a number. Subtract that number. 1 to the 3 halves is 1. So this says 2/3 plus c is 3. So I subtract 2/3 from both sides. I get c is 3 minus 2/3. That's 9/3 minus 2/3 is 7/3. So my function is, now that I know the c, it's 2/3 x to the 3 halves plus 7/3. There is the one antiderivative that has this extra special property that h of 1 is also 3. So this is like the slightly more complicated version of computing antiderivatives. More stuff we should be ready for. Back when we first learned the power rule for derivatives, just pause the recording, buddy. Back when we first learned the power rule for derivatives, I handled some goofy problems like what's the integral of x squared minus 2x plus 1 all over x cubed. And now you know the quotient rule. If you wanted to take the derivative of that, you might do the quotient rule. And after you did the quotient rule, you might kick yourself when I pointed out to you that that was more complicated than necessary because you're allowed to split that up into separate fractions. Well, for integration, we're not going to get a quotient rule. Integrals, I guess I'll talk more about this after this example. Integrals are more complicated than derivatives. There's not an algorithm. For derivatives, I can write down a gross formula and you follow the instructions one at a time and you write down the derivative and you get there. Integrals aren't like that. I just said I wasn't going to explain this, but then I did. More on that in a second. There's no quotient rule. You got to know you can split this fraction up. Split this into separate fractions. You get x squared over x cubed minus 2x over x cubed plus 1 over x cubed. Each of these things reduces and becomes just a power of x. This is 1 over x. This is 2 over x squared. This is 1 over x cubed. Each of these I can rewrite as an exponent. That's 2x to the negative 2. This one is x to the negative 3. This one I could rewrite as an x to the negative 1, but remember the power rule doesn't work on a power of negative 1. 1 over x is just fine because I know the thing whose derivative is 1 over x. It is natural log x. What's the integral of 1 over x? It's natural log x, but I gotta remember these stupid absolute values. Plus this one, add 1 to the exponent, get x to the negative 1, divide by negative 1, negative 2 over negative 1 makes it a positive 2. Add 1 to the exponent, I get x to the negative 2. Divide by that, I get negative 1/2. Plus c. Is this correct? If I take the derivative, do I get the right thing? The derivative is 1 over x minus 2x to the negative 2. Negative 1/2 times negative 2 is positive, x to the negative 3. That matches with this version at least. Yeah, I guess that's right. That's the basics of integration. So here's a good place to pause the video and, oh, actually, okay. I'm going to say some more philosophical things and then, okay, so one more video of me explaining some big picture stuff and then pause this and go do the first batch of homework.